The world population in millions increases from 2060. This is 1,260 million or 1.26 billion people in 1850 to 1650 in 1900. Use this to predict the world population in 1950. The actual population in 1950 was 2560 million people. Is our prediction an underestimate or an overestimate? First, any population growth follows the model dp dt equals kp, whose solution is p of t equals p naught, which is the initial population, e to the kt. With this type of problem, when we were given the actual year, we want to let t be the number of year, or it can be hours or minute, but in this case it is year. Let t be the number of years since the first year mentioned, which is 1850. What this means is that if we want to use the year 1850, we would use t equals 0 instead. Similarly, for the year 1950, we would use t equals 100. There is an advantage for defining t this way. First, we don't have to work with the large number in the exponential model. Second, if we set t equals 0, then the initial population in this case is 1260. What this means is that p of 0 is 1260. In the year 1900, the population was 1650, and so 1900 is 1900 minus 1850, so that is 50 years since 1850, and so p of 50 equals 1650. Armed with these 2 points, we will find the equation of the exponential growth. We start with the population growth model. P of t equals p naught e to the kt. If we plug 0 into t, this is p naught e to the k times 0, and we should get 1260. But k times 0 is 0, and e to the 0 is 1. And so p naught is 1260, and we update the model. P of t is now 1260 e to the kt. The parameters of this exponential equation is p naught and k. E is just e, and t is the variable of the function. And so we found p naught. We still need to find k. To do that, we use the second piece of information. If we plugged in 50, we will get 1260 e to the k times 50, because t is 50. And this should give us 1650, because p of 50 is 1650. To solve for k, we first divide by 1260, and the right-hand side is now e to the 50k. And to get to 50k, we ln both sides of the equation. We take the natural log. ln of the left and ln of the right-hand side. ln of e collapses, and it gives us 50k on the right-hand side. We will use the calculator to find k, so there's no need to simplify the left-hand side. The left-hand side is still ln of 1650 over 1260. K is 1 over 50. We simply isolate k by dividing by 50. So 1 over 50 ln of 1650 over 1260. Plug this entire expression into a calculator. We should get k to be approximately 0.005393. Try to give as many decimal places as we can. Now, we found k, which is another parameters needed, and so we update the equation. P of t equals 1260 e to the power 0.00593 t in the exponent. To predict the population in 1950, 1950 is 100 years from 1850, and so we plugged t equals 100 into the equation, and we type this into a calculator. We should get 2161. This is the number of people in million. And so in 1950, using this model, we estimate that there will be 2.161 billion people. Now, the actual population size in 1950 is 2560, but we only estimated that it is 2161, and so our model underestimated. And so this is an underestimate. The rate at which the population is increasing is higher year after year. When we predict a quantity that is outside of the data range range from 1850 to 1900. And so 1950 is outside of the range. This is an extrapolation. The result using an extrapolation is less reliable.